It's me here again. We're on interpreting two-way frequency tables. So we're going to do today's lesson. I will just be honest, this is a longer lesson. And usually it's a lot more fun in the classroom, but that's okay. We'll talk about how we're going to do it here online. So we'll go through today's lesson. You'll have some homework for tonight, and then tomorrow's lesson is just a work on your own kind of thing. So please don't hesitate to send me a message asking me questions about tomorrow's stuff, and I can take video of whatever I need to and post it for you guys. So just to give you that heads up, but they're both on the same topic. So this is interpreting two-way frequency tables. What you see here is a two-way frequency table. It's got one set of data or variable on the side and one set of data at the top. And so there's the two different directions that you can read the table, okay? So there's a lot of things with two-way frequency tables. You've got to really stop and read and think when you start looking at these. Okay. For this one, parents and students were asked how much homework their student or they had on a typical school day, and responses are below. So what you see here is that they were given certain choices, okay, of how much homework, the number of people that responded each one of those, the relative frequency, which is essentially your percent, just not as a percent, and then your percentage that came out of that. Okay. Now there's a major problem with this data. Okay. And it's really what it's saying right here is you've got to look at the question and then you've got to really read into this. This said parents and students were asked how much homework their student or they had in a typical school day. Notice that none of this is broken down by parents and students. Okay, so let's say that parents and students. Who said who were these 78? Was it half and half parents and students? Was it mostly parents? Was it mostly students? You don't know. So this is not a good representation of this data. Okay, a two-way frequency table in this case would make way more sense by splitting up these responses between parents and students. Okay. Okay, so one more thing before we get to what we're doing today, okay? Based on more of the survey, this two-way table was created, okay? So we're gonna have some definitions here, and I'm really just using this to look at these definitions. So what is a two-way table? We've kind of discussed that, and again, you don't need to know the definition of it, you need to know how to use it, okay? Each survey question can be treated as a variable where answers vary. So you were asked how much time, and you were asked if you're a parent or a student of an elementary or a secondary level student. Okay, so answers vary. We can see if there's an association between variables using the table. So we could look at something like for the number of people that say none for parents, is it similar to the number of people that say three or more hours for parents? Okay, there's lots of things you can look at, but association wise. And then you're going to have row variables and column variables, so time spent on homework and responded status and grade level. In this case, the row variable is just like it said, time on homework, so the rows across, and then the column varies respondent status and grade level, and that's the columns going down. Okay, so that's just the difference there. Other than that, we can leave that table alone. So just another representation of row variables and column variables. And the question here says, what association do you notice between the variables? So there's lots of things that you can say, but one of the most common answers I would get if we were in class is people will say that more men said yes than women. Okay. And the interesting thing here is you really have to read into this. Notice in the top left here it says percent. So these are giving percentages. Okay. And now then you look at it and you say, okay, wait, 59 and 49% of what? Because that doesn't add up to yes. Okay, the 59 and the 41 do, so that's your 100%. There's some iffy things going on here. And just because you see 59% versus 49% doesn't mean that more men said this. A larger majority of the men said this, you could say that, but let's just say we only surveyed 3 men and we surveyed 100 women. Well, clearly you're going to still have more women in that case that said yes. So you have to be careful about what you say when you're looking at two-way frequency tables. Make sure you know what it's really talking about. Okay. Okay, so what you see at the top of your page, based on a recent GSS poll, 58% of Democrats were female, 49% of females were Democrat, and 20% of the respondents were female and Democrat. Okay, now, a lot of people would think that's all saying the exact same thing. It is not. In this activity, you're going to explore various types of percentages such as those above, so we need to take a few minutes to think about what each of these percentages tell you. Okay, So if you look at each one of these, okay, the 58%, and I'm going to use an F for female and a D for Democrat, okay, this says of Democrats. That's saying we know that they're Democrats. So this is doing a probability given that you know the person is a Democrat. Okay, so there's my given there, my conditional probability. And it's saying which ones of those are female. So this 58% is the probability that they're female given that they're Democrat. Okay, now once I give you that, you can probably figure out the next one. This said 49% of the females. So you knew that they were female. Given that they're female, you're deciding that they're Democrat. So that's that probability. And then your last one here, 20% of the respondents. So this is of everybody. This is not conditional. Okay, we're female and Democrat. So how do you say female and Democrat? You do an intersection. And so this is the probability of that intersection. Okay, we're going to be doing a lot of this today. Okay, looking at those different things, and you're probably going to have a lot of questions about it. So we usually in class, I would actually hand out different little slips of paper, and we would figure out all of the class data based on the information that's here. So I would have, based on how many kids we had in class, if we had 21 kids in class, I'd hand out 46% of the 21 slips would say Democrat on them, 20% would say independents, and 34% would say Republicans. Okay. And you would just get a random slip of paper, and then obviously you have your gender that you would decide when you submitted your information. Okay, I just created class data based on similar statistics to above. I did this based on a prior year. So we're going to use some specific class data since I don't have a chance to pass this out to everybody. Okay, so part one, analyze class data. So it says summarize results from the class data in table one. So we didn't have a class data, so I'm giving you the class data. If you look at the red numbers here, we're going to say that 2 of the Democrats were female and 5 of the Democrats were male. We're going to have 1 female that's independent. We're going to have 3 males that are independent, 7 females that are Republican, and 3 males that are Republican. Okay. So table one is called a two-way table. We've already talked about that because it classifies students on 2 variables, their gender and their political preference, which I know both are very hot topics, okay? For table one, the row variable is gender and the column variable is political preference. Again, for the stuff that is bolded and underlined in this unit, those are essentially all the things that I would highlight on this one. So if you want to go through and highlight all of those right now, you can, but those are all of the big terms to pull out. Don't know a definition for those, just know what they are, where they exist, and how they're used, okay? The number in the lower right of the table is called the grand total. Notice we don't have one, okay? So let's fill in our table based on this, okay? And we talk about totals. We're going to have row totals that are going to be over here, and we're going to have column totals, okay? And then we have this last one that is our grand total, if we're talking about that. So our row total is 2 plus 1 plus 7 gives us 10 females that were in this class. 5 plus 3 gave us 11 males that were in this class, which means we had 21 total people in this class. Okay, total Democrats, there were 7. Total independents, there were 4. Total Republicans, there were 10. If I add 7 plus 4 plus 10, I should also get 21. Okay, so the idea of that total is that they should add up. Okay, so we are going to use the data that I just gave you right here for the rest of this worksheet. Okay. Number 2, let's begin analyzing the class data by calculating what are called marginal percentages. So this is your information on marginal percentages. Okay, these percentages, this is essentially a definition, involve one question or variable at a time. They're called marginal percentages because they are calculated from the totals highlighted in gray out on the margins of table 1. Okay, so the marginal percentages for gender. Okay, so if we do it based on gender, you're looking at the margins that are the 10 and the 11 out on the right side of your chart. Okay, relative frequency and then equals percentage we want here. So a relative frequency is saying how frequently does it happen? How many females? There were 10 out of a total of 21. That's my relative frequency equal to, and it says write it as a percent. So I'm not going to have you guys type these in. I'm just going to give you the percents as we go, but just you would type in 10 divided by 21, convert it to a percent by moving the decimal over twice. So this comes out to 47.6%. Notice it does say round answers to 1 decimal place here, so that's what I'm giving you. Okay. Males, relative frequency, there were 11 males. So again, the 10 and the 11 are the marginal numbers out of 21. 21 is the grand total. Okay. And this is going to come out to 52.4%. Okay, which comes out in this case to a total of 100%, which these should come out to, but we are going to talk about this in just a second here. Okay. Letter B, find the marginal percentages for political preference. So this would be looking at the bottom of the table 1. Okay, so this is relative frequency equal to percent. So Democrats, there were 7 Democrats out of 21, the grand total. So again, this is what we're doing here is we're doing the Democrats out of the grand total, and this comes out to about 33.3%. Okay, for independents, there were 4 out of the grand total of 21. This comes out to about 19.0%. And then for Republicans, there were 10 out of 21, which we actually already found that over here. So we know that that's 47.6%. Now, just to show you this, if you add these up, they should add up to 100. Well, those actually add up to 99.9%. Okay, for the purposes of what we're doing here, as long as you're within the 1%, you're fine for these, because some of you may have figured this one based on 100 minus the 33.3 and minus the 19.0. Okay, so as long as you're within a 0.%, you're good on these ones. But do realize that sometimes these won't come out to 100, but really this is 100%. It's just based on rounding errors here. Okay, so take this a step further, and the percentages taken together form what's called a marginal distribution, okay, in which the percentages sum to 100%. Represent the marginal percentages for political preference in a bar chart. Okay, so now we're working on something completely different, a bar chart. Okay, start with axes and labeling. So this one's actually done for you. So the axes are given to you, political preference, Democrat, Independent, Republican, and then percent, and there's numbers that are given to you there. Okay, so the axes and labeling are done. This is teaching you how to do a bar chart. Then draw rectangular bars of equal width above each category. So if we look at Democrats, we're looking at a 33.3% chance. So you just want to get close. You know that this is your 30. You need to be a little bit above that, below the 40, and you need to make a bar. So something like that. For our independents, we know it's 19%, so we're going to go a little bit below the 20. Just get as close as you can. You're not going to be perfect here, something like that. And for the Republicans, 47.6%, so close to that 50 that's in there, somewhere in here, and then we fill that in. Okay, so a bar chart, notice I have the axes, I have the labeling, I have rectangular bars, I have them of equal width, and they're above each category. Okay, if you wanted to connect yours, so if yours happened to be a little bit bigger and they ended up running into each other, that would also be just fine. You could do something like that. I'm going to go ahead and back that up so it doesn't look confusing when I'm done. Okay, so next, you will calculate percentages of the types reported in 1 through 3 at the beginning of this activity. So you're now going to calculate conditional percentages. Okay, letter A, find conditional percentages for gender. Okay, round your answer to 1 decimal place. So if you want to at this point, take the information that you had on the first slide and just kind of bring it with you as you go, so that you can calculate these, whatever you need to go through this. But essentially we had a chart that said female, male, Democrat, Independent, Republican, and was split up by, we had 2, 1, and 7, and we had 5, 3, and 3. So I'm just going to fill that in here so that we can refer back to that as we go through this. Okay, so your conditional percentages for gender. Okay, now this is where it gets a little bit tricky. This is a percentage for gender. So this is going to be what is the probability that we have a female given that they're Democratic. Okay, and this is where it gets a little bit tricky. So I would suggest you write a few extra pieces of information here, but this is how we're going to do it. So this is going to be the probability of, again, conditional percentages for gender are going to be gender, because we want percentages for gender given they're conditional, and the only other thing that we have is based on the politics. Okay, so if I want to go in here, we're talking about female and Democrat. It's going to be obviously probability of female given that they're a Democrat. Okay, so if I'm going to fill that in this case, given that they're a Democrat, so there's 7 Democrats, and how many females of those, so just looking at the Democrats, just these 7, 2 of them are female. Now remember, with conditional percentages, it's the intersection of the 2 divided by the given information. Okay, so the politics in this case was Democrat, that's 7, that goes on the bottom. And then the intersection of female and Democrat is right here, and that's the 2. Okay, so 2 out of 7 is where that one's coming from, and that's going to come out. Actually, I'll let you put the percents in here. I'm just going to put these numbers in here. Okay, that will come out to about 28.6%. Okay, if we do the same thing for independent, okay, so now we're thinking, so what is it? Gender is still female, politics is independent. Okay, so the bottom is going to be just the independents. So the independents, there are 4. How many of them are female is the 1. Okay, and then Republicans, how many, politics-wise, how many Republicans do we have? We have 10. And how many of them are female? We have 7. Okay, so those are the numbers we have. Do the same thing with male. Okay, so again, it's gender given politics. So this is now male given Democratic. Okay, so male and Democratic is 5. Given Democratic, so if you look at the totals for Democratic, it's 7. Okay, independent, male given independent. So there's 4 independents, 3 of them are males. So it's 3/4 of a chance. And then Republicans, 3 of them are males out of 10 total. And the reason the totals are down here is because these totals should add up to 100%. Each one of these are 100% as you go through. Okay, we do that again over here. Conditional percentages for political preference. So we want to find a probability of the political preference. Okay, and since it's conditional, given, and what's the other information we could have, and in this case, it's gender. Okay, so that's the way that this one is going to work here. And again, you don't have to memorize these, you do need to know these. So understand if I asked, given 2 other types of variables here, okay, the conditional percentages, just come back to what we have here and kind of replace the ideas, okay? So here, I am finding the probability of Democrat given female, okay? So I know that there are 10 females, and how many of them are Democrats? That's 2, okay? I know that there are 10 females, and how many of them are independent? There's 1, and there's 10 females, and how many of them are Republican? There's 7. This total adds up to 100%. Okay, do the same thing with the males. I know that there's 11 total, and I know that 5 of them are Democratic out of the 11. I know that 3 are independent out of the 11, and I know that 3 are Republican out of the 11. And that also adds up to 100%. But again, the big idea here, you can figure these out once you know this, but the big idea is understanding this, that find conditional percentages for political preference relates to that idea there. Okay, so asking some questions off that. In column 1 of table 4, okay, so we've got our table 4 here, column 1. The condition is Democrat. Explain why the percentages in column 1 sum to 100. Okay, so the fact that the 2/7 plus the 5/7 equals 100%. It's not the math behind this, okay? It's taking into the fact that we are talking about all Democrats there, okay? Now, why do we ask this? Because if you actually look at table 5, these two don't add to 100%, okay? Because it's not talking about all of the Democrats in this case. You have to go across the rows in order to figure out those percentages, okay? Based on your percentages in A, so based on what we have up here, which political party has a higher percentage of females? Okay, um, so we're looking at the percentages here, okay, which percentages for gender, so which political party has a higher percentage of females, and in this case, we're going to talk about the Republican Party. And what we're looking at is the 70% versus the 28.6 percent. Okay. So if we're looking at these two, we're looking at the 2/7 versus the 7/10, and so that's where we get the Republican there. Okay. Letter E, in table 5, you have just calculated 2 sets of conditional percentages for political preference. So this is what we're getting here. One for the females and one for the males. In row 1, the condition is female. Explain why the percentages in row 1 sum to 100%. So again, this is very similar to what we're talking about in C, but understanding that here, if you went across, you're not going to sum to 100%, but here, if you go across, you do. Okay, why is that the case? Because those 3 boxes at the top account for all of the females. Okay, so you can't, these 2 boxes here don't count for all of the Democrats. Okay, we got to talk about all of the females that are accounted for there. Letter F then talks about representing this information for political preference, one for females and one for males. So conditional percentages for political preference. So notice conditional percentage for political preference. We want to look up here, and that's B, okay? One for females and one for males in a bar chart. Start with axes and labeling in figure 2, okay? So we actually have some of this given to us. So we've got our females, males, Democrat, Independent, Republican, and then our percentages here. We need to realize that we've got to look at our different percentages. So these percentages up here go all the way up to 70%. So we want to make sure we make it to 70. So I went ahead and kind of skipped. I went 5, 10, 15, 20. Keep filling them in here to go through this. And I know this is kind of hard to follow on here, but do the best that you can. And then I went one above here to get to my 70. And now I'm having technical difficulties. There you go. So you're going to do that, and then you're going to start going through and you're going to label what you get for your rectangle bars. Okay, so here I'm looking at the females of the females who's Democratic, so this is 20%. So we're going to go up to the 20% there. We're going to talk about of the females who's who's independent, that's 10%. And then the same thing with Republican, and we get 70% out of that one. So that's that one that goes way up there. And again, do the best that you can. Drawing on here is not going to be great for me. Do the same thing with the males. So from the males, okay, 5 out of 11 is going to come out to 45.5%. So about 45, somewhere in there. Again, not going to be perfect, but you're going to get the idea. For the independent, you're going to have 3 out of 11, which is going to come out to about 27%. So we're going to go just below the 30. And then Republican actually comes out exactly the same there. And so we're going to get our chart and have something to that effect. Now, what can you use this chart for? Okay, you can look at some information as you go through. You can see what's equal to each other, what's lower, and so on. So based on your percentages in B and the bar chart in F, do the political preference of the females in the class differ from the political preference of the males in the class? Explain, support your answers by comparing appropriate percentages. So the answer here should be yes. Okay, I don't really think there's a way for you to say no in this one. They do differ. Okay, there's lots of ways that you can talk about this. I'm just going to talk through these. I'm not going to write them down. Some examples of what you could write, and feel free to go back and listen to this again. You could say more males are Democratic than females. I'm looking at a 45% versus a 20%. You can say more males are independent than females, the 27% versus the 10%. You could say more females are Republican than males, the 70 versus the 27.3%. Lots of things you can look at, but essentially you want to compare the bars that go together. Okay, and so that's kind of what you're looking at there. Okay, moving on from that, there is one final type of percentage that has not been discussed, and that's called total percentage or joint percentage. Okay, for this percentage, there's only one group. There's the whole class. However, the sample space consists of all possible combinations of outcomes from the two variables. Okay, gender and political preference. So what is the sample space? Okay, remember we list sample space, S equals, and we do a little curly bracket. Okay, and I'm going to use FM, DI, and R in this one. Okay, so we're talking about these total percentages or joint percentages. Okay, so we have female and Democratic. Okay, these two put together. We have right here, that's going to be female and independent. We have this box here, which is going to be female and Republican. Okay, and then you do the male and Democrat, male and independent, and male and Republican. Okay, so that is your sample space. Find the relative frequencies for each of the outcomes in the sample space, convert these to percentages, and record them in the white cells in table 6. Okay, so relative frequencies for Democrat. So again, I'm going to go back and I'm going to list this female, male, Democrat, independent, Republican, and we have 2, 1, and 7, and then 5, 3, and 3. Okay, it helps to be able to refer back to this, so I'm going to go ahead and do that. Okay, so here, if I'm looking at this one, okay, we're saying how many are female and Democrat. And so that's going to be 2 out of the total of 21. Now, these are total percentages or joint percentages, so they're out of the entire thing. Okay, that's going to come out to about 9.5%. Okay, for the female and independent, okay, female and independent, we only have 1. 1 out of 21 is going to come out to about 4.8%. Okay, Republicans, we're going to have 7 out of 21. Sorry, Republicans and female. So we have the 7 out of 21. That's going to come out to about 33.3%. Actually simplifies to 1/3. Okay. If we look at the males Democrats, okay, we have 5 out of the 21. So that's going to come out to 23.8%. The independents that are males are 3 of them out of the 21, which comes out to 14.3%. And we have the same percentage on Republicans that are male. Okay, so we have all of these percentages here. I'm just going to separate all of these numbers. There we go. Okay, so then you have these totals, okay? So then sum the row and column entries to complete table 6, okay? So we have 9.5% plus 4.8% plus 33.3%. This comes out to a 47.6% there. We can add the 23.8, 14.3, and 14.3. That comes out to 52.4%. Now, those numbers should actually look familiar. These numbers right here are the marginal percentages for gender. Okay, what you're going to see here is that this table essentially gives you all of the information. Okay, if we sum down, we have 33.3%, we have 19.1%, and we have 47.6%. Okay, these three numbers that we just made are the marginal percentages for politics. Okay, and then they total to 100% each way. But again, that could possibly be off based on rounding. Okay, so that is your information. There's a lot of information there. I do expect some questions on this, so please don't hesitate to email me with questions, but you are going to then go through and finish part 2. Okay, part 2 gives you data, so it gives you a whole new chart on different data, and then asks you to answer similar questions to what we did in class today. Okay, so that's what you're going to do, and then you're going to go from there using the same type of ideas there. So understanding and going through, just to go back through this, your different kind of variables, giving your totals, okay, going through your different marginal percentages, going through your conditional percentages, and then talking about your total percentages. Okay, so go through and do that, and let me know if there's any questions.